everybody. Good morning. Oh, you know what we can't do on stream? Listen to copyrighted music. And that's one of my favorite activities. Listening to copyrighted music. Do I look glowing? Do I glow this morning? I'm trying to glow. Welcome to my stream. Now, hopefully, you guys don't see that warning because we are not smoking weed on this stream. I've learned that it was very bad. I was also banned from LinkedIn. They've really been cracking down on me hard. I have a narrative and they don't want you to know my narrative or something. I don't know, man. You can just read conspiracy theories everywhere. You can walk around paranoid like the John Nash. Let's close the door because Alex is sleeping. I don't want to disturb Alex. Oh, welcome. Oh, you're not seeing the warning. Are you guys seeing the warning on my thing, on my content? If you're seeing the warning, we gotta go somewhere else. This is a wholesome stream, wholesome Christian stream, boys. Christian stream, boys. Good, no warning. This is a wholesome Christian stream, boys. Now, welcome in. For those that don't know me, my name is George Hotz. I was a child prodigy, and like all child prodigies, people had high hopes for me, and I ended up fulfilling all those hopes. So yeah, there's that. If you're actually new here, don't worry. I don't actually take myself seriously. If you're worried about that, a lot of problems in the world would be solved if people just took themselves less seriously. But you got to take yourself less seriously, but you got to take the future seriously. I think those are difficult concepts to hold in your head. No, it's not ASMR. We have to be quiet because Alex is sleeping. Anyone who's loud, you're getting banned. PyTorch has RL. Oh, I know about torchrl. No. We're not doing decision transformers today. I'll show you what we're doing today. So, I've added, so this is tinygrad master. And I've added an option to shard across GPUs. So this is running 7B llama here. We can run it on one GPU. And give it a second here to load. So we're SSH'd into a tinybox right now. For those of you that don't know what a tinybox is, it's a box and it's not really tiny. That's kind of a misnomer, but here, I will demonstrate it for you. So we just go here to test GPU. A tinybox is for, you can pre-order right now on tinygrad.org. A tinybox is a $15,000 very powerful AI computer. So when you see things like the Rabbit for $200, you're much better off buying a mid-range Android phone in terms of power per dollar. When you see, I think there was another one, I don't even remember the name, but like when people are selling AI computers in the $1,000 price point, buy a mid-range gaming PC. It's going to be hard on the low end to compete with phones and with gaming PCs. But there's very little in the $15,000 mark. The closest you're going to get is maybe something from Lambdalabs. Like, let's see what we can get for $15,000. Maybe a vector GPU workstation, get pricing. Here, so something like this. So this is a little bit cheaper. Let's see if we can customize it to be a little more powerful. This is a cool company, by the way. I'm not trying to hate on Lambdalabs here, but I think that we are providing a better price than they are. We need what? Can I customize here? Okay, so I mean, we're gonna have to do a little. There should be a way for me to customize and get. How do I click customize? How does this work? Okay, here. Let's just compare it to this one. So this one costs a bit more. Yeah, this is actually probably a good comparison. Actually, it's almost a perfect comparison. So you're getting pretty much the, for $15,000, you're getting something that compares to a $37,000 lambdalabs computer. We have, so instead of 3 GPUs with 48 gigs, we have 6 GPUs with 24 gigs. They're 7900 XTXs. Instead of this Threadripper Pro, we actually have a very similar CPU. I can show you the one we're using, but it's the same 32 cores. So it's this AMD epyc. We don't have that much RAM. I don't think you need 512 gigs of RAM. We only have 128 gigs of RAM, but remember that tinybox is less than half the price of this. Our hard drives are a little smaller. So this one is not, let's go over to Tiny 7 here. Tiny 7 has the full RAID array in it. So if you like cat proc MD stat, you'll see that we have 4 very high grade NVMe drives connected on PCIe 4, and I can demo this for you. Let's do like 128 meg block size and count 100. And then I say like I flag equals direct. There's a sudo. Oh shit. Yeah. I think we can make this go faster if we do more. Should be a little faster. Why is this not as fast as it was? Is it not iFlag direct? It is iFlag direct. Does it matter where I put it? Can't matter where I put it, can it? Huh. Okay, I mean, that's still kind of an insane speed. I don't know why we're not getting... When I was doing this test before, I was getting 28.7 gigabytes per second. I posted one on tinygrad's Twitter. Oh, of course this isn't going to work because it's not logged in. Oh well, I'm still pretty happy with that. That's going to be a lot faster than one U2 NVMe, right? This one U2 NVMe can't exceed. I mean, it can't exceed 7 gigabytes per second. So this drive is over twice as fast as that, and I'm sure I just misconfigured something, and it should actually be faster than this, but whatever. Oh, someone linked it. Thank you. MD0, iFlag direct, BS equals 256. What? How come it was faster before? Why did it get slower? It moved to MD127, but that shouldn't change anything. Why is it slower? This is the same computer. There's a few of those. possible those are causing a problem. Well, we'll have all these bugs worked out by the time we actually ship tiny boxes to people. Why is it faster there and slower there? This doesn't make any sense. Okay, let's look at the drives individually. Okay, 7 gigs on that one. 6 gigs on that one. 6 gigs on that one. There's got to just be some kernel garbage. Weird. Why don't those 4 add up? Have I done a kernel update? I don't think so. Built on November 14th. It's not mounted? I think that matters. Weird. We're gonna have to get to the bottom of this before we ship. Why did yeah, I know it's not. I don't think it's running on the computer. Reboot and try again. Okay. Oh. We changed processors. Well, that's not good. We put a different processor in this one. We had a 16-core processor. It's CPU limited, I agree. We had a 16-core processor, and we switched to a 32-core processor, and now this is slower. No, it's software RAID. Yeah, it's kernel dumbness limited, I agree. Wow, wait, that's a real problem. Okay, well, we'll fix it. I mean, it may not matter what. I think that DD is just... look, I'm sure you can get that speed. I don't like that it's... I was using... I was using... This was the old processor I had in there, but I was like, no, I want a better processor. But to be fair... it doesn't have as high of a core speed. And that's not good. Yeah. Okay, so this is 2.4 gigahertz. This is the processor that's in the tiny box. Like this one's much cheaper. I wish I could use this one, but I didn't want to use it because it wasn't a lot of this one's double the cores. Could be the IRQs are on the wrong NUMA node? Maybe. Wow, but that, I mean, that's crazy. All I did was swap this processor for this processor, and now it's slower. All right, that's the really cool thing about the tiny box is we're going to be able to spend a lot, because they're all the same, we're going to be able to spend a lot of time tuning and really zeroing in on, look, first off, this isn't a bad speed, but we're going to spend a lot of time zeroing in on how to get this thing exactly right. DD is single threaded too. I think we can, it sounds NUMA. Yeah, I agree. Well, that computer's gonna take forever to reboot because it's a server motherboard. And in the meantime, we can play here with Tiny9. Is tinybox like a Raspberry Pi, but for ML? Exactly, yes, you understand. What if they stop producing? Well, I don't think they're going to do that. So we're getting 24 tokens per second when we're sharded on one GPU. We can do beam search and it can go a lot faster. If you want to see it be fast, it's just kind of cool. But yeah, you can see this is the full connectivity matrix between these GPUs, which is insanely fast. So now it's searching for the fastest ways to do things. Can I late beam on Llama? Let me see if I can late beam. Can't late beam. All right, is this computer back? Still rebooting. I did not buy a Apple Vision Pro. Oh, Genu. Oh, there's no late beam. Yeah. So we'll see how fast we can get Llama to be with beam. But then I'll show you sharding, and ooh, fastdd. Ooh. It uses splice. I'm not sure that's gonna fix it actually. We can try it. Oh, 15 stars? Oh, I didn't even look. Yeah, I don't think that's gonna fix it. So you see what beam search does? It searches over all different sorts of kernels that can run it, and then it finds the ones that are the fastest. I did not buy an Apple Vision Pro. It's very expensive, and you know, money's been tight lately, boys. Started a new company. We haven't had stupid money to throw around at things. Maybe if Bitcoin goes back to 100K. Oh yeah, Meta did buy a lot of H100s. Man, Jan LeCun, you know, what a mensch. Yeah, maybe if Twitch gave better splits. At least they removed the content warning from my channel, which was really very offensive to me. I also I got banned from LinkedIn. If you want to check out my LinkedIn, I wrote a nice post about how I was banned from LinkedIn. Maybe if we can get to it, not logged in. Here we go. Well, we're gonna have to read it without this pop-up. Maybe can we just get rid of this pop-up? Let's get rid of this pop-up. All right, there we go. So I thought maybe I'll read to you my LinkedIn apology. I was banned from LinkedIn. A terrible tragedy, I know, is why would they ban one of the best people on this site? But then I read the LinkedIn professional community policies. See picture below. I'm deeply sorry to everyone that I offended saying that I use LinkedIn as a dating site. I understand now that this website is not for that, but instead is for serious business discussion. If you're interested in dating, you might consider following me on Instagram @GeorgeHotz. Again, if I offended or upset you, I'm very, very sorry and will take this ban to deeply consider how my words have an effect on the people in this community. Words matter. The choice of words matters. Saying I use LinkedIn for dating is wrong. A better choice of words is saying I use LinkedIn for professional networking. I hope you accept my sincere and heartfelt apology. I have updated my profile to be more sensitive and inclusive in hopes that I can continue being a part of this wonderful place where you can freely speak truth to power. So hopefully LinkedIn understands and accepts my apology. Professional networking. By the way, the real joke of it is LinkedIn is the most absolutely god-awful dating site in the world. The women who DM'd me asking for dates on LinkedIn, oof, yeah, it's not it, bro. It's not it, bro. Sell the rolls for Vision Pro. The rolls coin is down. Rolls coin is down. If someone's interested, I'll sell the rolls. I'm telling you guys, I didn't make a lot of money last year. Like no joke. I started a new company and it doesn't make money. Not yet. That's why we're selling tiny boxes. Wait, what? How is this still not back? Whatever. So yeah, we're gonna have to look into why this processor made things slower, and we're gonna have to fix that. Want to go work for Twitter again? I'm not really a good fit at Twitter. I think it's a lot better now that Elon bought it, but it's not really a product I like. I think that what Twitter did for the culture war was so incredible. It's great. I love the way that I feel things are moving this year. You see my post on Twitter from yesterday. I think we are finally kind of moving past. It's not even I really am kind of a progressive and agree with some of the tenets of wokeness, but there's just a lot of very angry people, angry and like doomers. It's the doomers and the decels. It was never about the culture war was never about some return to conservative values or anything like that. I don't support that. I don't agree with that. But I don't want to hear the use less energy people, the build less housing people. I don't want to hear from them. I don't think they should have a seat at the table. And it's nice the way that things are, that a kind of positive message. I was at a dinner party with Peter Thiel once, and I've my respect for Peter Thiel has grown a lot, but for a long time I didn't like his just the negativity and the complete lack of a positive vision for the future. Just kind of bashing. It's not really great, man. It's I want to see a positive vision for the future. But I think there's a great one. I saw a post yesterday from someone saying I see two groups of people here. One group of people says that I have privilege and wants to make me feel bad about myself, and the other group of people is EACC, and honestly these people seem super welcoming and awesome. Yeah, I like that. I think being welcoming is really good. Thiel. This party was maybe 2017, and I was not a Thiel fan in 2017. But I think he said a bunch of things in the last 5 years, and he was right about a lot of stuff. So my respect for him has grown a lot. We don't like gatekeepers. We don't but I don't want to harp too much on this. But as far as the question was go work at Twitter. It's not. And maybe this is why the culture war does have this asymmetry to it, where the kind of people who want everybody to be miserable and eat the bugs or whatever are the kind of people who are excited about building a mechanism of like large-scale social control. I don't know. Like, as much as I participate in social media, and that's as much as I participate in social media, it's just not that like exciting to build. I'm not that interested in controlling people. And it's sad that the people who are interested in controlling people are mostly sort of evil people. Okay, is my computer back yet? Okay, my computer's back. I kind of think that rebooting is not going to do anything. Yeah. So let's see what we can do about this. That sucks. Like, I put a better processor in and it got slower. Let's understand the difference between these two processors. So these processors, I went from, I'm using this one now, from this one. So we have 8 CCDs and 1 IOD. Oh no, I switched to this one, I think. Let's see. Oh, this one. Okay, how do I get the boost clock? Turbo boost, boys. How do I get CPU power? Oh, this is a good point. How about just that? How fast is that? If copying from dev0 isn't fast, can you open dev0 with iflag direct? No, you can't. Dude, my drive's literally faster than dev0. Wait, that's kind of a, this is like a, how fast is this? Oh, that's a cool test. Okay, that one's faster. Oh, whatever. All right, let's see my CPU frequencies. Right, let's oh wait, is turbo boost enabled? Wow, this is literally like a, oh, turbo boost is already enabled. Okay, I don't have this CPU power function, and I don't trust any of these. Maybe Linux tools common? That seems like a harmless package name. Did I boot with mitigations equals off? Oh, I definitely got to turn that crap off. Wait, yeah, that sucks. I want more frequency than that. Can I write to CPU max frequency? Wait, no, we gotta enable the turbo boost. No, the block size is fine. We gotta. Do I have CPU power now? What the hell? Oh, I I need to install this. Wait, this is getting sketchy now. CPU power? Okay, we're good. Frequency info. They promised me a boost frequency. Promised it. They promised me a boost frequency. How do I enable the boost frequency? Boost. We need some boost, boys. How do we get the boost? Boost is not activated. Okay, well, let's enable boost. But it says I have boost enabled. Boost. To enable boosting. Oh, I don't care about saving energy. Can we stop that? Use more energy. Okay, how do I... Ooh, here. To activate a particular... How do I check what governor I have? Yeah, it's faster. We unlocked the boost. Okay, but it's still not as fast as the other. Oh no. Oh no. We only... Oh, that one was fast. Oh, well, actually, let's just go longer. It's fine. This might actually be right. Be as fast as the other CPU. I think we only get a little boost. All right. Okay, it's faster. It's faster, but we need more boost. Let's check that dev 0 thing. That's probably a good benchmark. We really got to go directly from the GPU to the disks. Is this faster now? Oh, it's a little faster. Okay. Wait, so how do I get like super boost? Is there more boost? No, it still doesn't look like we have boost. Wait, active no. Wait, how do I, yeah. How do I enable boost? Okay. I'm gonna go into Vim and I'm gonna change active to yes. Okay, that's what I want. I want boost. Boost. Okay. How do I enable boost? Come on, Perplexity, hook me up. No, I did that. Don't tell me I have to buy a license for boost. Wait, oh shit. What if it's not enabled in BIOS? Oh, that sucks. Okay, how are we gonna get access to BIOS? We can't. I do have IPMI, but I need like a password and stuff, and I don't have that. Wait, boost is just gonna make everything better though. As soon as we enable boost, oh, it's not an overclock. It's just I have IPMI. I have IPMI. I just don't have the password to where I can access it on stream, which kind of sucks. because this says boost is on. But then this says boost is off. Maybe if I sudo. Oh, wait, what? Wait, I was joking about that. But if I sudo, we have boost. It's an ASRock board. Sudo. Oh, sudo enables boost. Okay. Well, no, but I have 0 boost states. We need more boost state. Okay, so like I thought that this CPU was fine, and it probably is, because the boost speed of these two is the same. What the hell is boost anyway? What is boost? Epic boost, not boosting. Exactly, that's my problem. Ooh. Well, that didn't work. See, but the great thing about tinybox is we're going to enable all this stuff. Oh, wait. This guy had a bad time with boost. Oh. Damn it. How come I can't edit BIOS from... Maybe parameter of how much to... What the hell is CPB? Okay, well, we're going to have to wait till next... The stream isn't even about boost. We're going to have to wait till next stream for boost. But I promise I will come back and we will get boost working, and we'll make sure that we can read from this at lightning fast boost speeds. Again, a huge advantage to the tinybox is I'm going to waste days of my life, perhaps even weeks of my life, tuning this shit for you. So I'm going to get some more coffee. I'll be right back. Unless if someone figures out the magic incantation to enable boost, I will try it. This is false advertising, that's right. So wait, does the base clock actually matter? Look at the boost on this one. How much do these cost? Wait, that's pretty cheap. Would people rather this CPU? No, I know how to ipmi. Cheap Epic or vendor locked. Yeah, you gotta watch out for vendor locked, but I don't think this is vendor locked. Wow, wait, this one's so cheap? Oh. I kinda like that. Wait, and it has... Wait, I kinda really like this chip. See, it's no locked version. The CPUs aren't ancient. What are you talking about? Maybe we should test this. Okay. Do you want 32 cores or do you want 16 fast cores? think you might want 15 fast cores. Both? Well, you can't have both. How much faster? It goes from, the base is 2.4 up to 3.5. The thing that I like about this chip is it draws more power. Okay, I'm gonna buy 2 of these. Sorry, I gotta disable the screen while I do this. No logins. No locked version. Good. I hate locked version. Oh shit, I forgot I have credit card issues. That should work though. No, I think that... I'm not happy about any of this. But like, no, if we just enable turbo, we can get most of the gains. We just need to enable turbo. It's kind of wildly fast though. No, these are way better than Threadrippers. These are really good CPUs. Oh, if I click on each, I get more info. Okay, this is the CPU we've chosen for tinybox. Turbo 1 core. Yeah, we should be able to get 1 core up to that speed. Nobody like really dives into this stuff. People are missing out on so much performance. Oh, okay, that's the single core. Let's look at the single core of that frequency boosted one. Now, but you need all the cores in order to like do data loading. $446 versus 683. But then again, like, do I trust this benchmark? Did they enable boost? Do they know about boost? I don't know if they know about boost. Wait. These are better than Threadripper Pros, okay? Threadripper Pros are just shitty epics. They're literally just downbinned epics, boys. They are. What is this image? Is this appropriate for stream? Boost! No, we're going with that 32-core CPU. We're going to figure out how to enable boost. Look at the stats. Well, yeah, because that's a Milan chip, okay? That's Milan. I think so. That's Milan, right? Milans aren't really worth it. Ooh, that's a lot of boost. Ooh, that's fast. Ooh, we love boost. Alright, you found something that looks promising. I think I just have to enable it in BIOS. I think it's a BIOS issue. Yeah, we did that. It's actually crazy though that that's what's a btop? Let's get btop. I've never used btop before. That sounds like a... Yeah, bro. You heard of htop? You heard of azitop? Well, now we got btop. It just stands for black screen. Oh, btop! Yo! Wait, btop's pretty sick. We like btop? Look at btop. Alright, let's like go like 5,000. And we can see which core is being used. Oh yeah, poor core 53. Really throttled at 100% here. Btop's sick. I love the colors. Wait, it's PCIe 5.0. Oh, you have a. I mean, look, I have it here. You want You want that? You want that? Do you want that processor? PCIe 4 is fine. No GPUs have PCIe. All right, I'm done defending things to you. PCIe. No GPUs have PCIe 5. Right. Your btop. Okay. All right. I said I was not going to get triggered this stream. We're not going to get triggered. Oh yeah. Doesn't help if you want to sell hardware. Look, okay, this is why democracy sucks, okay? Because in a direct democracy, everybody votes for more free shit and less taxes. And the problem with more free shit and less taxes is there's no more government after a while, okay? So you guys can put in your Milan, and why don't you sell the tinybox for $9,000 while you're at it? And then we lose money, and then there's no more tiny boxes, okay? So that's what you all did. You got rid. You killed the tiny boxes because you wanted to buy overpriced CPUs, and they don't even really matter. We just need to enable boost on the CPU we have, okay? This is a pro-Singapore stream. That's right. If you don't believe in Singapore, get out of my stream, man. I've been to Singapore. You know what? I wasn't afraid that I was going to be stabbed by crack addicts. Because they don't have that there. It's illegal. What is a tiny box? Bro, where even are you? No, this CPU is great. We're just going to need to enable boost. And I don't know how I got distracted, but I started showing off the boost speed is the same on this CPU and on this CPU. But it is cool that once we enable boost, we're going to get a free 37.5% boost. This one goes up to 3.9. That's a 62% boost. The ideal country is 50% Singapore, 50% New Jersey. Yeah, some days I miss New Jersey. Is the tinybox software too specific that if CPU changes, it can become slower? Yeah, if you put a Pentium 3 in it, it would become slower. No, it's not that specific. But I did switch out the CPU, and then it can no longer, a single thread can no longer keep up with reading from my beast of an array of hard drives. So, but we'll fix this by enabling boost. Okay, so on to what we were actually going to do this stream. Uh-oh. It's complaining about privilege. That's not good. Who told it about privilege? Wait, that's really bad. Chenyu, what happened? Why can't I beam llama anymore? Wait, that's really bad. Okay, well, we're not doing any more demos on stream. Don't worry, this will all be fixed by the time we ship the tiny box. Okay. I know. Yeah, it was like, yeah, it's complaining about privilege now. All right, great. So we're getting 24 tokens per second when we shard it on one GPU, but we can shard it across two GPUs and watch how much faster it is. So now we're sharded across 2 GPUs, and look at that. It's almost it's more than 2x slower. So yeah, it's slower. So that's a big problem. And if you look at why it's slower, it's interesting. It's because the NQ time is, look at the difference in NQ time. You know what would make this faster? Boost. No, the bottleneck is not the GPU. The bottleneck is HIP graph is fake. So they have this API called HIP graph. Close that. Close that. This. All right, so there's this API called HIP graph. Let me take a look at it here. Well, it's not really real. So this is a CUDA graph. So you can batch all of the kernels into a graph. But here, so let's take a look. I can show you what it's actually doing. Startup times of that seems slow too. Oh, it's because I'm not. Okay, so if you want your startup times to be faster, again, this is just something that like I'm gonna have to add. I'll add something in to do this. If you put a watch on rocm-SMI, it doesn't put the GPUs into low power state, and it starts a lot faster. So great. So you see all these xvers. So all these xvers are really slow, mostly because it has to do synchronization. Code to do that is in ops hip. No, it's not in ops hip. Here. So we have to block the GPUs like between them, and you can put all this stuff. I spent 4 hours yesterday putting all this stuff into the HIP graph, and I thought that the HIP graph would be fast because the CUDA graph is fast, but the HIP graph is not fast because HIP graph is not that well implemented. So that leaves us basically with 2 choices to make this fast. By the way, I can show you guys something crazy. We can run 7dB llama now. So we just need to shard it across 6 GPUs. Like this is loading llama 2 7dB. By the way, look at how fast it loads. That's those drives, and as soon as we enable boost, it's going to be even faster. The inter-GPU connectivity is in the. This is a public driver. I'm not using any special driver here. This is just ROCm6. No, not quantized. You think I fuck around with that? Look at the RAM used. Look at that RAM. Look at that RAM. You think that's quantized? So that's full llama 7dB. Unfortunately, it's very slow. It gets about 1 token per 10 seconds. So we're going to have to make this faster. But it's not the GPUs at all. The GPUs are really good. The whole problem is that I'm doing it all from a single thread. So we kind of have 2 choices here. We can refactor tinygrad to be multi-threaded. And by multi-threaded in Python, I mean multiprocess. See, there we go. It's generating. Oh, it's 0.07 tokens per second. Yeah, I know it's slow, okay? But it's not slow because of the GPUs. The GPUs are barely even being used. Don't trust that 100%. That's wrong. The slowness all comes from the CPU because I'm using a single thread to do all this. So the problem isn't even a Rust rewrite. I'll show you what happens. So we have code here. Let's just focus on the 7B across 2. I can add profile to the end of this. Well, so the ggml approach is not what I want to do. The problem with the ggml approach is you always have a time horizon whenever you're writing software. You can think about, do I want to make this fast tomorrow? Or do I want to make this fast for applications that haven't even been written yet? And ggml has heavily opted on the side of take modern models and make them fast on modern hardware. Which is like, they're both on the Pareto curve. But tinygrad has a very different goal. Tinygrad's goal is to make models that exist in 5 years fast on hardware that exists in 5 years. So we want to design things that are really universal. So you can see that the slowness is coming from these two functions here, event and block. So rewriting it in Rust actually wouldn't even make it better, because all the slowness is in these two functions, hip event record and hip stream wait event. These functions are actually making syscalls. I added in a flag called ioctl. Actually, did I get that flag in? No, I didn't get that flag in. Okay, we got to merge that. ggguff is just ggml. I have a branch for this. What's it called? Cleaner events. I have to get this merged. Doesn't even have the. So I wrote this code that can do here this. So we can look in here and look at the ioctls. And this is all just setup, allocating memory, fine. But you see these wait events and set events? So this is just one of the things that's responsible for the slowness. These event record and wait stream events are making syscalls into the kernel. So, okay, let me first explain what the wait and sync are. So when you have two GPUs working on a problem, you have to figure out how to keep their two queues in sync. So HIP has this thing where I can tell one GPU to wait, basically, tell GPU 2 to wait on an event from GPU 1. These things seem really poorly implemented, unfortunately. So that's why it's not fast. I could potentially fix this in the GPU. Okay, so you have three basic ways to fix this. One way to fix this is to try to use, like, as soon as you've compiled something and pushed it to the GPU, that overhead's no longer on the CPU. So I could write a spinlock in a GPU kernel, which is, instead of using the event primitives, I can just have GPU repeatedly poll a piece of memory on the other GPU and be like, is it set, is it set, is it set, is it set? The problem with doing this is it's ugly. It's clearly not the way the GPU is intended to be used. It probably is faster in practice, but it just bypasses all this nice stuff that you can actually use, and I'll show you in a minute how we can get to the nice stuff. Another solution is just the brute force solution. Each one of these GPUs could live in... one thing that's going to make it 30% faster is enabling boost, but another solution is to use multiple threads. So when you do multi-GPU stuff in PyTorch, or at least multi-GPU training, you put things across threads with distributed data parallel, or actually across processes. And the downside with doing this is it becomes a lot harder to think about. Everything's much easier to reason about when it's all a single thread. As soon as you go into multi-threads, things become harder to reason about. But multi-process would get us down, would make things like 6x faster if we're using 6 GPUs. The third solution is to write our own GPU driver. So all of this slowness is coming from user space. We don't actually need this user space. There's a big complex HIP user space that seems egregiously slow. So, okay, prereq. For those that don't know what HIP is, there's a thing called AMD HIP, and it is a clone of CUDA. AMD literally said, copy CUDA's API as closely as we possibly can, but put HIP in front of everything instead of CUDA, and you can look at the runtime API reference, and you'll find that these things are basically identical to CUDA. Like here, HIP event create, wow, let's see. CUDA event create. Oh, the CUDA events API, interesting. CUDA event create. CUDA event create with flags. That's in the part of the screen you can't see. CUDA event record, HIP event record, CUDA event destroy, HIP event destroy. So you can see that these are basically just clones. See, instead of returning a CUDA error T, it returns a HIP error T. Error T. So yeah, yeah. Unfortunately, NVIDIA's stuff just seems much better implemented than AMD's stuff. The CUDA stuff isn't that fast either, but at least CUDA graph seems to be real, whereas HIP graph seems largely to be like, I bet there's a lot of, well, the other thing about HIP is we can read the code. So we can actually look into HIP graph and see if it's all the things that we claim it is. So let's read the code for HIP graph. So HIP is also in a bajillion different repos, and you never really know which is the real one. This one looks kind of legitimate, so let's try it and see if we can find the HIP code here. There's also this cool flag we can set. Two flags, AMD log level and HMTK debug level. So we can look and see what's actually going on here. So this is like a graph here, HIP graph launch. Where is hipgraph.cpp? Is it in here? Oh, hipgraph.cpp, sweet. Or we can also read the code of what's slow. So it is really cool that AMD did make all this stuff open source. But the problem is, what's interesting, they have all this capturing stuff. I wonder if I can just use capture. Is tinybox running a custom Linux? Bro. So yeah, this graph stuff seems slow. So basically we have two solutions. One is multiprocessing and the other is writing our own driver. And we wrote the pros and cons on the whiteboard yesterday. No, the problem's not the data loader. The problem is literally dispatching enough stuff to the GPU. Okay, wait. So we have three solutions potentially. Spinlocks, multiprocessing, and writing our own driver. Spinlocks and multiprocessing, probably you need both of them to make it good. If we write our own driver and it really works, we can get almost zero overhead to relaunching GPUs. So let's see if there's a noob tutorial to explain to you how GPUs work. How do GPUs? Let's ask Perplexity. How do GPUs work? What's a command queue? See, like, the problem with using spinlocks is the command queues have all of these fences and semaphores that we should just be using, but it doesn't seem like there's a way that we can use these in the HIP API without making syscalls and doing lots of complex stuff. Okay, you found something good? I think I might have taken this class. Is this computer graphics? How GPU works. Yeah, so this is like old school stuff. like whenever you're talking about fragment shaders and vertex shaders, there's like so many levels to how a GPU works. Like this stuff's all correct and you should understand it, but this doesn't get to almost what the API to a GPU is. Okay, one built a chip. Oh, that's cool. Yeah, I was in this guy's parallel computing class. You get into stuff like latency hiding and warp scheduling, but we're not even at that level yet. I'm just talking about how you actually talk to a GPU and why this stuff is slow. So what this API does is build up these things called command queues, and you can see them here. It's called hardware queue. Let's read rock-virtual.py and take a look at the hardware queue. So it's called AQL, virtual GPU, dispatch generic AQL packet, insert packets, packet store release. So what we really want to do in our driver is pre-build the queues, leave them on the GPU, and then remember, deep learning is running the same thing over and over and over again. So we have the queue on the GPU, we just need to ring the doorbell. It's called a doorbell on NVIDIA. It wouldn't surprise me if AMD just copied that terminology. Qualcomm's Adreno doesn't call it a doorbell. Qualcomm's Adreno has an ioctl to do it. Does chat know what MMIO is? HIP does not expose semaphores. Maybe it does? That's actually a good point. What's an external semaphore? Can I use a semaphore? Something to sort of think about is, yeah, actually, what if I don't have to spin lock on the GPU? What if there's like a spin lock primitive? There might be. Synchronization functions. No, I don't want sync threads. Actually, that's just an interesting idea. Atomic functions. Atomic add. Read more. Resulting in global or shared memory. Is there a spin lock primitive? Well, again, a lot of this stuff is more, sure, you can like have these things, but how are they actually implemented and are they fast? Then we need to start shoving atomics in our stuff. And then global memory. Can this go across GPUs? Ooh, can I trigger the copy from a kernel too? Okay, I mean, this is all way less. Okay, the two choices we put on the board yesterday and did like pros and cons on. One was multiprocessing, and the other was writing our own driver. But there may be a third way here, which is to just shove everything in the GPU kernel. Actually, let's look at the instruction set. So AMD does a good job of documenting their GPU instruction sets. So maybe we can just find something here. What is send message? Send a message upstream to the... Whoa. See, okay, in general, my philosophy is we need to look at what the hardware is actually doing. Wow, this stuff gets deep, bro. See, I told you about doorbells. You thought I was kidding about doorbells. You're like, you don't have doorbells on GPUs. Well, they do. So, you know, you were wrong. Make me a little smaller so you guys can see better. Floating point atomics, program flow control, introduction. So what these things are probably in practice, if we can somehow like send a message. Congrats, no sub-only mode guy. You got sub-only mode enabled. And you can't even say anything about it because you're not a sub. Send message was the most interesting thing. Software generated interrupt. Where do these interrupts go? The problem also is none of this stuff talks about the AQL command types. So we're probably going to have to look in the code for this because I haven't seen this stuff documented anywhere. Here. So this is a dispatch barrier packet. So this is a barrier and packet. Let's see if we can find like the spec for AQL somewhere and we can... Why doesn't it find that? Where is this defined? Oh, here we go. No, is that what it's... Static const expr. So, yeah, like, again, I don't know how anyone ever understands computers. There's so much complexity to all this stuff. So this is only talking about the instruction set architecture. That's what runs on the shader. But then the GPU also has a scheduler, and the scheduler seems completely undocumented. Where the scheduler even lives is questionable. So you can look, there's firmware on the GPU. There's this thing called a micro engine scheduler. Let's see what Mixtral knows about it. Perplexity, come on. Called micro engines that are integrated into each compute unit. GCN3. What's the new one? Hello, we stream. It's Alex on FaceTime. Do you want to say hi to the streamies?
No.
Oh, you don't want to say hi to them? Okay.
Okay. I'll see you when I go to work.
Oh, you want to work? Do you want to? We can walk to. Well, I already had coffee. I got this coffee, but it's not that good.
What is it?
It was in the fridge.
Oh, it's downtown. You want to walk to lunch?
Ooh, lunchies. What time is that? So early for lunch.
It's a perfect time. No, because it takes 40 minutes to go anywhere.
Where are we going?
Well, I could get ready now.
I got a shower.
30 minutes. You do?
Yeah.
You look like you should.
I look like I need a shower?
No, you look great.
Thank you. Wait. How was waking up this morning? Was it good?
It was so good. I love being alive.
Oh, that's good. Being alive is good.
Yeah. But you weren't here, so I was upset about that.
Well, I tried to wake you up, but you were sleeping, and then I'm like, what am I gonna do this morning? And we streamed. We learned about Boost this morning.
Boost?
Yeah, the tinybox has Boost, but it's not enabled.
Oh.
And
I mean, like, we're gonna boost this place.
No, it's not like that, man. It's not like that. Like, what's a booster? You know, like that seems like something that sits on a school board.
On a school board?
Yeah, or the bottom of a rocket.
Oh yeah, you're right, a booster.
You know, like a booster, like they go to like homecoming and they're like, I'm a booster.
Words are hard.
How many hours is it going to take you to get ready?
Why did you put a plural on that?
Hour? Well, is 0.5? Do you say 0.5 hour or 0.5 hours?
I'll see you in 0.5.
No, but how crazy is that? It's 0.5 hours, 1 hour, 2 hours. Like there's think of that graph, and there's just a discontinuity at 1 where you say hour.
We ready in 30 minutes.
Oh, 0.5 hour.
Yeah, 0.5 hours.
That sounds nice. I don't know how much longer we're gonna spend on this stream. I feel like I'm kind of ripping the people off if I don't give them a good stream today, but also, I removed my content warning. I could just click it off.
Wow. Okay. Also, you could come back after lunch and do more streaming.
I could come back after lunch and do more streaming.
You don't have to like only stream now.
No, I think I do. Well, I feel dirty and like I have to shower.
I'm not gonna. Okay.
Yeah.
I respect that. Do what you gotta do, George.
Where are we going to lunch?
Do you know where I've been wanting to go? That deli that's run by the cult.
Gratitude Cafe?
No, there's another one, a famous one in San Diego.
What's it called? It's not called Cafe Gratitude.
That's a different cult.
Do we have to drive to Cult Deli? How far is Cult Deli?
I'm gonna find out right now.
Okay. Do they have sandwiches? I don't like deli. Is it like cold cuts? What does a cult make?
We'll look into it. It's called like yellow something. It's in my notes.
Oh, I went to one of them. They had one of them by my parents' house in Durham.
A yellow deli?
Yeah. My dad said it's run by a cult.
Wait, what? They're everywhere? They're spread out?
Yeah. And I was like, we all live in the yellow submarine. It's like that, but it was a deli. That was all I was thinking about when I went to the deli. Alright, the stream people are upset that I'm giving you attention and not giving them attention.
I forgot you were on stream.
Yeah, we're on stream. We're just hanging out, man. We can't say anything racist, you know? She hung up on me. Irish boyfriend, George? I'm Irish, that's true, bros. Irish Catholic. No, we're too poor to afford Naval Vision. Okay, where were we? We were looking to see... I remember what we were going to do. We were going to read the code and see if we can figure out all the packets that we can send to the GPU. So we have a flag here that we can set called JIT equals 1, and then JIT equals... Oh, no, sorry, it's JIT equals 2, and it won't put things into the graph. Let's load. We're loading. Okay, now it's running. Okay, good. So you can see here we put a barrier end in, but there's also sometime we can queue actual kernels, like here, command kernel execution and queued. Hardware queue dispatch header. Okay, let's maybe we should take some notes. So whether we end up writing a driver or not doesn't really matter, as long as we understand what all the code is doing and we understand what these things really are deep in the GPU. So like, do we want these shader processors doing synchronization, or do we want the micro engine scheduler doing synchronization? I think the answer is we want the micro engine scheduler doing synchronization. And I don't even know if it's actually the micro engine scheduler. I'm just ripping it off. Okay, so there's also multiple of these. So this is GFX 10. The 7900 XTX, I'm pretty sure is GFX 11. Where'd my perplexity go? Which GFX is... What? How do you not know about this? Which one of these is like, oh, I don't know. Maybe this one know about it? This one knows about it, but it doesn't know what a GFX is. Well, so much for using AI to do our work for us. You know, everyone who thinks AI is going to do their work for them is sorely mistaken, man. Like, remember that time that we got plows? That was a fire post. Someone like photoshopped the AI is going to be fundamentally labor destroying, and someone crossed out the word AI and wrote plow. BTFO, Mustafa Sullivan. What a loser, man. No, we're not hating, bros. We're not hating. We're not hating. He bought... No, this is a hate-free stream. That's right. In this house, we love everybody except people who are bad, like, you know, those people. Okay, you found something? Is this good? The driver should expose synchronization across devices. It does, but the problem is it's really slow. Oh, I've seen this before. Let's read it. Blah, blah, blah. Skip the introduction. Okay. Boing. Yeah, this is kind of interesting. So we're in rock clear right now. Shared pool of default. What's a coup mask? What's a CU mask? HIP runtime inserts a kernel launch command into a software queue managed by the rock-clear runtime library. Oh, architected queuing language. Interesting. inserts it into an HSA queue. We had an HSA, Home and School Association. AQL packets go in the HSA queue. In hardware, an asynchronous compute engine processes the HSA queue. Okay, kernel's journey to HIP's stream interface is backed by a software queue, not an HSA queue. Once a kernel launch reaches the head of its software queue, rocm converts it into an AQL packet. In order to send the AQL packet, we copy the AQL packet into an HSA queue. HSA queues are ring buffers of AQL packets and are directly shared between the GPU and user space memory. Strict memory sharing allows it to, yeah, okay. It may seem like an intuitive choice to back each rocm queue with a dedicated HSA queue. But see, now we understand why everything sucks. Because one software queue may work to different HSA queues, and each HSA... I want to rip all this crap out. Let's just generate HSA queues from tinygrad. Right? If we can just like as soon as we can get the queue, tinygrad should output an HSA queue, copy it to the GPU, and be like, do that shit. After receiving a run list from the driver. Oh, this is really good. Thank you for the link, sir. After receiving a run list from the driver, the GPU's top-level command processor using hardware scheduling. Questionable whether it's hardware. Hardware and firmware are synonymous. You'll never understand what that means. Some of you might. Who understands what I mean when I say hardware and firmware are synonymous? Knowing this, we can finally explain why rocm attempts to limit the number of HSA queues used by any single application. The GPU hardware can only support up to 32 concurrent HSA queues. 8 queues on each of the 4 aces. What the hell's a coup mask? Oh, a compute unit. Oh, so I can mask and see which compute units it goes on. Oh, this shit's fire. Okay. We'll now describe how the kernel at the head of an HSA queue gets assigned to the computing hardware. Call the thread blocks or the basic schedule entities. So when kernel dispatch AQL packets reach the heads of their queues, the question becomes how the GPU decides which blocks to run and where to run them. One of the more prominent features is the division into shader engines. So this is some esoteric terminology. Workload manager. Okay, like what is this and where is it? See, I can, yeah. HIP Extreme create with coup mask. I can mask it and only put it on some compute units. This is way too complicated, boys. Okay, I think we should just make HSA queues. Goal: have tinygrad output HSA queues. Then we can just load the HSA queues, output, and dispatch HSA queues. So, just like copy these. These seem pretty good. Okay, so we have barrier and header. Don't word wrap. Ew, word wrap's disgusting. Okay. And then we also have command kernel execution enqueued. Oh, here, dispatch header. Perfect. Oh, it's word wrapping. Ew, don't word wrap. Okay, you know what? This is not word wrap. I'm going to make you a .txt file. Yeah, txt doesn't word wrap. That's right. Okay, so we have dispatch headers, and wait, why is this a different dispatch header? Why does that one have a different number? That one, oh, because it's on a different hardware queue or something? I don't know. We also have another kind of thing here. Let's see this exfer. So we do a HSA copy, which doesn't look like it's on a queue or something. That I don't really know. There's also sometimes, yes, so see sometimes these barrier ends have a depth signal and sometimes they don't. So like here, we can get that one, and then I think the next one of these will have a depth signal or something. The depth signals actually do work out to be oh, that's cool. So you can see how the completion signal here is this HSA copy, and then like it's the same as this. So you can see this depth signal is the completion signal on the copy. So I don't exactly understand how async copies go on hardware queues. Maybe they don't. No, they probably do. I don't know why it doesn't like print it out. All right, let's look at all these hardware queues and see if there's any other ones that I missed. Barrier end, dispatch, barrier end, barrier end, dispatch, barrier end, dispatch. Okay. I'm assuming these hardware queues are HSA queues. Oh, okay, good. Well, we see all these. Okay. What's a hardware queue here? GPU queue base address. What type is a GPU queue? Where does this come from? Oh, it's in a virtual GPU. Great. That's what we love, man. This is like React. Love seeing virtual GPU. Where's this queue? Where's the queue? Okay, hardware queue engine unknown, hardware queue engine compute. We're going to end this stuff with one queue. We just want a queue, and we're going to make them in tinygrad, and we're going to put them on the GPU, and it's going to run them, and it's going to be happy. Perplexity AI can justify their, I don't know, I don't think 520 million is that crazy. I don't give them money yet, but I probably should. Like, they're one of the first. I think that one way to tell, like, a good proxy for evaluation of a company is it the thing that you go to often? What companies are insanely, like, look at Cruise and Waymo, right? Nobody's like, oh yeah, I'm taking a Cruise or a Waymo. Like, nobody says this. So they're overvalued. But a good proxy for the value of a company is like, is this something people actually like use? You know, and it is. Wait, I'm getting distracted. You're a subscriber. You're not supposed to distract me. We're working here. Okay. So let's figure out where all this HSA, like, I want to understand what is the structure of an HSA queue? Where's this file? Is it somewhere else? Where is that file? rocm debug API. Oh, is it in the rock kernel driver? Might be. Okay, so rock kernel driver is actually a kernel. So that's going to take forever to clone. It's just pronounced rock. It's not pronounced rock K. Does Perplexity give better results than OpenAI? It's not to support open source. Perplexity is way faster. OpenAI is so slow. GPT-4 is unusably slow. I don't use it anymore because I'm not going to sit here and wait while it types things out at 10 tokens per second. Like, I have things to do, boys. GPT-4 still is unquestionably the best. And if they made GPT-4, my OpenAI subscription lapsed due to some issues I've had with the bank. Don't get me started on the bank. But yeah, so I let my subscription lapse and I don't really care. When they get GPT-4 to be 100 tokens per second, I'll subscribe again. What about Anthropic? Yo, no, Claude's a piece of shit. Also, no, I tried Claude like once and I was like, oh my god, this is... Also Llama, I mean Llama 2 Instruct is so RLHF'd into stupidity. I heard a great quote about Anthropic. Anthropic stopped to think if they should. They didn't stop to think if they could. No, I like GPT-4. It's just too slow. But also, who's distracting me right now? We have work to do, boys. We got to learn about HSA queues, okay? Is this where HSA lives? Where's that file? It literally includes something called AMD HSA. Is that in here? That's concerning. Where is it? So where is AMD HSA.h? There's rock clear as well, but this has to actually be somewhere. Oh, I found it. I don't know how it got there, but ooh, okay, that's like kind of interesting. But like, where's that file? Yeah, can someone find this for me? Which of AMD's 27 rocm things contains that file? This had an interesting view. Oh, I know what we need. We need here. Heterogeneous systems architecture, HSA, and runtime. There is like a runtime thing in here, I think. Rock R runtime. HSA runtime API for rocm. No, let's see, maybe it's in this one. Oh, we found it. User mode API interfaces and libraries necessary for host applications. Actually, there's a chance we just want to use this directly from tinygrad. The HSA runtime provides direct access to the graphics hardware. So AMD calls this like level 0. Ooh. It's also in HSA foundations. I mean, is this is still being updated, right? Like they here add rocm v6. What got added? Oh, they just changed the. This API also seems pretty stable. so where's the like... image core? Okay, I mean, this seems like the most interesting stuff. And we may very well just want to use, this and not re-implement this. Is a thin user mode API. Okay, is there documentation for this anywhere? No, they just have source, no docs. 8 years ago, yeah. Wait, is this a book? Wait, this doesn't make any sense. If I buy this, what do I get? Oh, it just has the wrong picture. Anna's archive is the new, this is the new hotness. If this works, I'm going to donate to Anna's archive. Fire. When I was donating to EACC organizations, the person who runs this reached out and asked for donation, and I was like, I don't know, people who ask for donations for things I don't use, I don't really like. It's not like, it's like fine, but now I'm actually using it, and I use this, and it found me another thing that was really good. So yeah, I think we'll donate to Anna's archive, because human knowledge should be free, boys. The FBI's coming for me, man. You know what happened to Kim.com? He also thought human knowledge should be free, and now he thinks the US is going bankrupt. All right, so let's see if this book's any good. We got a book coming. Not downloading fast. I think I subscribe, I get the fast downloads. This is GPT-4 speeds, boys. Okay, so the best thing we found so far was this runtime. Okay. Runtime initialization shut down, system and agent information, signals and synchronization, architected dispatch, memory management, HSA runtime fits into a typical software stack. Direct access to graphics hardware to give the programmer more control of the execution. What I want to be able to do is build a queue and then dispatch the queue. So Metal, if you read the Metal implementation in tinygrad, Metal has the best one. Like, Metal exposes most accurately what a GPU really is. I don't know why you can't reuse these command buffers, but you have command buffer, compute command encoder, and then they build a stupid graph API on top of it, which is like dumb. Like, you shouldn't have to, like, there's no difference between, okay, I get why they get, it kind of makes sense actually. Never mind. I take back what I said. They have a separate command buffer and indirect command buffer, which I think it's because, like, you can't change these things after you dispatch them. But Metal has the API that best shows you how GPUs work. I actually forgot how good this kind of was. Like, aside from the weird Objective-C isms. All right, let's see. My apologies for the copyright infringement. No copyright infringement intended. I'm concerned. Whenever it's trying to unify things into a single platform, I'm concerned. Extended runtime API. Ooh, are there like demo apps of this stuff? That'd be cool. Okay, we have HSA signals. Oh, here. Ooh, look at this. Ooh, this is exactly what I was going for. Okay, we have kernel dispatch packets, agent dispatch packets. What's FBI, man? Barrier end packet, barrier or packet, a vendor, not a vendor, it's a vendor specific packet. And then we have invalid packets. Well, that's an important packet type. No, it's a vendor. It's not a vendor. Don't get it twisted. Okay, uses an enumerator HSA packet type T to enumerate all types of packets. Let's see if we can find it in here. Oh, look, extra packets. Oh, okay, great. Now we have the packets. Barrier end allows an application to specify up to 5 signal dependencies, so that matches what we've seen over here. So there's 5 things there. The packet processor will not launch any further packets into the queue until the barrier end packet is complete. The barrier end packet is complete, blah, 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 blah. The packet format for vendor-specific packets is vendor-defined. The behavior of the packet processor for vendor-specific, but must not cause privilege escalation. Okay, we've been whining about privilege again. Okay, something. Don't care about images. All right, memory model. Okay, well, let's learn a little bit more about where HSA comes from. Multi-vendor collaboration to define a new systems architecture. I don't know. I don't trust any of this. Okay. Previous example, we've seen kernels. We have to understand how kernels are dispatched. Okay, great. Oh, we have a packet processor. Oh, we have a micro engine scheduler. Ooh, you found better stuff. Okay, let's see what we got. I like this less. It's a clock compiler. CL offline compiler. By writing the host code, compile to HSAL. What is HSAL? Yeah, I don't like the okra. That tastes nasty. What is this? Why do I want this? Great. I can target Ubuntu 14.04. Okay, HSA Q create. That seems good. The queue can support multiple producers, multiple threads. Okay, I get that, I guess. Oh, we got soft queues and hard queues. Soft queue. Custom prior. It sounds slow. Okay. All right, we're back to the barrier type, but here they're vendor with an O. Very different. Well, good thing we're not using any vendor-specific packets. We're basically only using, kernel dispatch and barrier end, I guess, are the only ones, except how is it doing the HSA async copy? Is that being put on the queue? Is that just a kernel? No, it can't just be a kernel, because if it's a kernel, I'd see the kernel dispatch. Okay, what is that doing? How is that dispatching? You see what I mean? So I understand how to dispatch kernels, and I understand barrier ends, but how am I doing the copy? Is it using a vendor-specific packet? Let's take a look. Which one is it? Dest equals this one, okay. Async copy on engine. Where's this? Oh, is this defined in here? It's in rocr runtime. Which one's this again? That's rock clear. This is all too hard for me. Okay, copy memory on engine. Great. DMA copy on engine. I feel like I've looked into exactly this before. Oh, well, you can't do that because that's an HSA status error. You don't have enough status. Decide to use the DMA copy on engine for P2P copies. Due to a RAS issue. Oh, well. Submit linear copy command. Blit kernel. Insert barrier packets. Boring. Where does it actually submit the command? Depth signals. Insert dispatch packet for copy kernel. Oh, it's kernels. Kernel type, copy aligned. It's just a fucking kernel? That's a scam. AMD is for people who can't afford NVIDIA. No, 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 no. AMD is for people who like getting twice as much GPU for their money. Right? You say can't afford NVIDIA. I say I have 2 GPUs and you have 1. Okay, so wait. No, it can't just be dispatching a kernel. That's such a scam. You're telling me this thing doesn't have a copy engine? So the problem with it using a kernel is that means it uses the same resources, and I don't want to do that. CUDA has a different, I've looked into this all with, I have a GitHub project where I did like low-level CUDA stuff, and CUDA actually uses a different engine to make the copies, but it seems like here there might not actually be a different engine, which really just sucks. And I feel like I actually knew this, and that's just really lame. Well, I shouldn't think about that. Like, one thing we could potentially do is get rid of the copy kernels entirely and just have it read off the other GPU. I wonder if that's faster. Is tinygrad going to have a pay per token API? No. What? But okay, so this is actually just launching a kernel, it looks like. Let's look at the kernel. Where does this kernel code go? Populate Q. What is populate Q? Blit kernel, populate Q, blah, 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 blah. Yeah, it's just a packet type kernel dispatch, which is the same as... We can probably even find the code for it then. No. Okay, there has to be. It can't be this. There has to be something else. No. This is like the crappy one. submit linear copy command. Insert dispatch packet for copy kernel. Why are there phases? Can I find the code for this kernel? Obtain async kernel copy arg. Signal started, blah, 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 blah. Copy device to device enqueued. Is this really just a kernel? Like, I wish they'd just tell me. I don't see another. Okay, what are these? Here we go. What are these things? What are these SDMA engines? Okay, it's possible there's not a kernel version and I'm just not using it. Submit command. Oh, okay. SDMA packet copy linear rect. Ooh. I kind of just wonder, like, maybe this. Oh, gang leader. Build fence command. Build atomic decrement commands. So how does this actually talk to the HSA? An agent that doesn't support platform atomic. See, the cool thing is we're just going to tune it for the one thing. I want to remove HIP support from tinygrad and I want to replace it with HSA support. And if you have a non-RDNA 3 AMD GPU, you can just use OpenCI. What's a GCR? Where are these things going? Where do these packets go? How do they get submitted, and why is this not telling me anything about this? Oh, interesting. Look at this. Okay, so there's two calls here, and I don't understand why it's not using the engine. It doesn't even tell you. So there's use regular copy API. If engines preferred in SDMA. Interesting. No, the MI300 is not RDNA 3. It's RDNA. Well, they call it CDNA. It's GFX. It's basically RDNA. It's GFX 9. So this is one of the like. I wonder if like investment analysts understand this. Here's some alpha. Okay, so NVIDIA has managed to keep their data center GPUs architecturally ahead of their consumer GPUs. Hopper is a little bit better than Ada. What was A100s? I forget the name of the A100s, but like there was like Ampere, A100, Ada, and then Hopper H100s. So they've managed to like do this like stutter step thing. AMD has RDNA, GFX 9, RDNA 2, GFX 10, and RDNA 3, GFX 11. So their data center GPUs forked off at GFX 9, and they're still architecturally the same as the RDNA GPUs. Who knows? I mean, who knows what hacks they've done on top of it, but just when you see a fork like that, it doesn't bear well for the company. So interesting. This is the copy function here. You can see that there's two options here. There's async copy on engine, and there's async copy. So there are engines, we're just not using them. So the big advantage to using the engine is you can overlap the copy with compute. And this is really important when you're doing things like ring reduce. Although the compute might be so fast compared to the copy that it may not matter. Oh, that's actually an interesting idea. We can play with that. I think that a GPU might be able to pull directly from another GPU. NVIDIA has better shit than they're showing you? No. No company ever has better shit than they're showing you. Companies are always showing off their best shit. You have to understand this. Like, the myth of... We used to talk about the secret good version of OpenPilot as a joke. Like, I don't know how you think that companies somehow have the secret good one and don't show it to you. What about OpenACC? So where's that actually defined here? Why can't it find it? Is bad pointer, copy memory on engine. Wait, dude. Note that VDI HIP will call DMA copy instead of DMA copy on engine for P2P copies, but we still want to handle 4 split kernels in this function in case other libraries decide to use DMA copy on engine. So in other words, HIP doesn't use the DMA engines. if I read that right. Which do you think is better run? The DMV or the NSA? Okay, so this is what's using the kernel here. Oh, here we go. Okay. So there's AMD Blit kernel and AMD Blit SDMA. So this is AMD Blit kernel.cpp and this is AMD Blit SDMA. Blit is like it's an old graphics term for copy. Blit. Blit. It doesn't even seem to mean copy, but like you put the sprite in the hole. Great. Okay, so we have Blit SDMA. So where does this command get submitted? So do you see what I'm trying to figure out? So if you look at HSA, like great, we have barrier ands and we have kernels. And we can probably do everything just with those two things, but then we're missing out on the great SDMA engine of the card. It also there might be like no way to synchronize this without like polling in the kernel, which would really suck. Okay, after transfer is completed, where does it actually do the command after all polls are satisfied? Doesn't seem right. How does any of this work? Want to use type ending? What do you mean by that? Build poll command. What is SDMA HCP flush? Issue cache invalidate, issue cache write back. Do the command? Is this the command? Okay, where is this? How come? Wrapped index command size, build poll command, acquire. What kind of command is that? It doesn't even work. Like none of this code's even enabled. So, I mean, in reality, maybe we just do want to read across the GPUs. I'll have to play with that stuff. Build fill command. Where's the copy? Okay, so it seems like it acquires a it gets access. Okay, so here it gets some data, it gets some place that it can put the command. It adds a poll command, it adds a get global timestamp command. It adds an HTTP flush command, but only if that's enabled. Then if this is enabled, it adds a maybe it's just this generic command. I see. So it like Where was that memcopy? It's just memcopy is the command. So these are just like things around the command. Here. But this just, okay. So this just like shoves the command in there. So I see what it's doing. This isn't where the copy command actually comes from. It just puts like boilerplate around the command and then copies it in. So where is the submit command called from? Here, so like here we build the copy command. Let's see what we can find. I don't know why it's not working. Okay, so this is the copy command. These are the commands for the SDMA engine. For VI device. What's a VI? Is this even supported on my shed? It seems so old. Call is blocking until the command execution is finished. Call is non-blocking. Okay, so let's go back to submit command and let's see where actually this gets written to the GPU. Okay, we build the command up. Where does it submit it? Where's like the queue that it actually submits anything to? Okay, so this makes sense. Like the get global time step command. Again, is this in the context of, oh, it's all in the SDMA engine. Okay, so we're in AMD Blit SDMA, which makes a lot of sense. I see. I wonder if what this is using. So we can. It's like maps the memory to the other GPUs. Does AMD log level not work? Why is it only KMT stuff? Why does AMD log level not work there? Is this not using HIP? Is this using lower level stuff? How does rocm-bandwidth-test work? Because that's actually getting that good bandwidth. What does this shit use? Oh, look, it uses the HSA APIs. That's interesting. Okay, but it's still not using the copy on engine, but we could imagine the copy on engine. Okay, so this is just using the blit kernels, but where is this HSA KMT debug level? And what else can I enable that looks kind of like that? I don't know. Can I enable... Do you think it uses SDMA? I doubt it uses SDMA. I don't think SDMA works. Lib HSA KMT. I feel like I've looked into this before too. But still, it's wild. So this is just using the KMT API. Sorry, just using the HSA API. Right, we get rid of rocm, we switch to KMT. Seems very usable. But then again, if that's just using a kernel, then we don't really care. Let's take a quick look at the HIP kernel launch API. You got out of the bed? I'm on stream.
I'm just peeping.
You can come in and say hi, but you can't just hang out at my door. We should really have some elevator music. We could do that, but it can't be copyrighted, okay? HIP module launch kernel. Let's take a look into this. Non-copyrighted elevator music. It says no copyright, okay? This is like the meme elevator music. I love this. Okay, guys, I'm gonna play you the hidden song. Oh no, it's not on this computer. It's not on this computer. You're out of luck. I was gonna show you. I released a song and then it got taken down for copyright, and I was gonna play it for you, but I do own the copyright to Die Now, sort of. I don't know how copyright works. Okay, which yeah. Break the internet, ban like Dr. Disrespect. Remember olden days before when you could buy a check. I'm all over the training set. I guess I'll live forever. I'm sorry about the future. It's just not what we expected. There's still cartoons on the hotel TV, and there's still a world outside, but I haven't seen it in a while. Nobody asked for this, but we're still gonna get it. Moloch marches forward in a sea of dead connection. You can't swim upstream for too long. You'll get tired and die and retire. I'm tired, you guys. Forget the machines. The world is so unaligned. You can't fight back. I don't know why you try. You are the new horse. Go softly into this dark night. You have 3 choices. Wirehead yourself, die, or live in a dark place where it's always fake outside and all the jobs are contrived. The singularity's arrived. I just didn't think it would suck balls. Okay, we're gonna look at this and see if this actually, does this give me like an event that I can synchronize on? Because maybe we can just do everything we want from HIP, and that brings everything full circle. Wait. If non-null? Oh. But this is so much better. So first off, I should be timing using this. And I can pre-create the APIs, but maybe that's free. I don't know. Let's read the HIP code and look. A lot of times you say you're going to write your own driver, and what you end up doing is just realizing that, you know, like you just like going on a journey. You go on the journey and you realize that everything you wanted was right there the whole time. I like signed up for some service that had like T's in it that like tells you what the weather is, man. You know, it's like the Mean Girls girl. Oh, it's gonna rain. You know. Start event, stop event. I want to figure out if these events are actually real. I guess there's no way to really know until we put them in the thing. And that would involve writing code. We're not writing code today because it's Saturday. My job to write code. We're just reading and shit talking. That sounds pleasant. Okay, we have a layer of indirection there. Where's that? Start event. I'm trying to figure out like how real this is. Start add marker. What's a marker? It's not even in there. Oh, okay, so this is the command NQ? What? What's command? AMD command. Oh, okay, so we like put it in this, and then we can NQ there, and then we find the stop event. Okay, that's cool. So that's interesting. I could probably use this stop event and make things quite a bit faster. That solves half the problem. That solves the event record half. Let me check and see if the graph API supports this. I don't actually know what the graph... It is really cool that HIP is open source and I can just read this. Like if it was CUDA, it would just be hopeless. So here, you have this function called HIP graph add kernel node. HIP kernel node parameters. Kernel params. No, this doesn't look like it supports it. What are kernel params? Does one of those kernel params include a what? What is this struct? I love root grab. Where is this defined? Why is that not there? Am I not in the right? No, I'm in. That should be in clear, right? Why does this not work? It's right there. I see it. Clear HIP AMD source HIP graph internal.cpp. Something's just wrong. Why doesn't this work? Stupid crap. No, okay, but this still doesn't get to the bottom of the fact that it's re-enqueuing everything every time with the graph. But this might be able to make things a bit faster. I mean, we know that there's real completion events, so I wonder if we could actually like use them. So what I mean about like there's these. Oh, well, that has completion signal set to 0, but some of these have completion signals. I guess I'm kind of curious what a completion signal actually is and how low level that gets. Of course, that search. Oh, that search worked. Okay, barriers active signal. How complex is this? This is a virtual GPU. Peep signal +2 ahead to see if it's done. This is going to go into the actual, this HSA API. Here. Q agent is mess. Allocate non-paged if it's the mess. Non-page system memory. When you write your own driver, you own it in all future changes. I mean, yeah, that's true. The question is, what APIs do we think are going to be stable? And it looks like this HSA API is both stable, and obviously if that API is stable, the things that it talks to have to be stable also. So I do think these things are pretty stable. But I think we could probably just use this. I don't think we have to go lower level than this. I should be able to add this to GPU C types pretty easily too, which is cool. I have this library called GPU C types. So we can add an HSA wrapper here as well. Like, yeah, this looks, we don't have to go lower level than this. Okay, great. So we don't actually have to write a driver, we just have to use HSA. So where are the, that's AMD extension, HSA X interface. C++ shit. All of hacking is just binary search by hand. So how do I like, is there like an HSA example of kernel dispatch? Heterogeneous system architecture programming model. Architected queuing language. It's cool that this is all like open. I wonder how many people know about this. Like, I've met a lot of people who know a lot about NVIDIA GPUs, but I've never met someone who really knows about AMD GPUs. Plain HSA system should allow agents to access shared system memory through a common HSA unified address space. The minimum is 648 bits. Yeah, I mean, the problem with that stuff is it doesn't tell you how fast any of it's going to be. Oh, actually, no, we should read about signaling synchronization. That's right. Stop discriminating. HSA signaling primitives. An HSA signal value must only be manipulated by kernel agents using the atomic memory, boring, user mode queuing. Containing packets defined in the architectural queuing language. Okay, we still never got to the bottom of how we dispatch the SDMA packets. So this is copy on engine. This is one implementation here in agent. So that's like the stub in agent.h. But if we look at the one inside AMD GPU agent, that's real. Then we come down to submit. Wait. Isn't submit linear copy command the one that doesn't use the engine? Yeah, no, this is the copy kernel. So wait, that's AMD GPU agent. So it's not this. Then there's that blit SDMA. Okay, but we like this rocr runtime. You want to try to build it? It's kind of fun, right? What does rocr runtime depend on? HSA rocm contents of these packages is installed in rocm HSA by default. Oh god, I mean the runtime's all here, which is cool. I guess, oh, I mean, we can sort of ask that question here. Like, they show it off here. So here we go. Like, we can just bypass HIP and rockclear and just use this. And obviously, we're not replacing the driver. I don't think we have to. I think this arrow is a fine place to step in, which is cool. We don't have to write a whole driver. We just need to use this because this is really what, like, what you're getting. HSA Runtime Programmer Reference Manual. The rabbit hole goes deep, boys. Why was my first thought that the HSA Foundation did January 6th? That was like my first thought in looking at this. I'm gonna get sued for that. I'm kidding. I don't think they did January 6th, okay? I think that was the FBI. I'm kidding. I don't think it was the FBI. I think it was evil people. That's right. That's right. Non-profit foundation. What's HSA? This is like the virtual parallel ISA. No, okay, we definitely don't want this. Like rdna is fine. Oh, good. They updated Chapel. Here's a programming language with 0 stars. Has anyone heard of this? What is all this stuff? Okay, can I get this manual somewhere? Here. Here's version 1.2 of the manual on Scribd. I have to subscribe with a free trial to get access to it. What happened to that book I torrented? We're closing windows. We never do that enough on stream. Okay. We should be able to download it from the HSA's Foundation's convenient website here. Okay, well, which one do I want? The Runtime Programmer's Reference Manual. Wow, this is actually... Why didn't Google find this? Wow, Google sucks balls. Like, the download link was right there. Wait, we love the Heterogeneous Systems Architecture Foundation. I apologize for any comments associating them with January 6th. I take it back. I don't think they did it. George, you can't just say stuff on stream. I can, and that's why you can't make clips. Words matter. Didn't your LinkedIn apology mean anything? Didn't you mean the words that you said in your LinkedIn apology? Okay, and if you missed my first reading of it, we're going to do a second reading of it. I was banned from LinkedIn. A terrible tragedy, I know. As why would they ban one of the best people on this site? But then I read the LinkedIn professional community policies. See picture below. It actually very clearly states that LinkedIn is a professional networking platform, not a dating site. I'm deeply sorry to everyone who I offended. PewDiePie, can you review me on your next apology video? Saying that I use LinkedIn as a dating site. I understand now that this website is not for that, but instead is for serious business discussion. If you're interested in dating, you might consider following me on Instagram at George Hotz. Again, if I offended or upset you, I am very, very sorry and will take this ban to deeply consider how my words have an effect on the people in this community. Words matter. The choice of words matters. Saying I use LinkedIn for dating is wrong. A better choice of words is saying I use LinkedIn for professional networking. I hope you accept my sincere and heartfelt apology. I have updated my profile to be more sensitive and inclusive. in hopes that I can continue being a part of this wonderful place where you can freely speak truth to power. Okay, so they ripped off CUDA, or CUDA ripped them off, who knows? The best one? Okay. What am I actually looking for here? Brig? That's where they send bad people in Star Trek or a boat. Binary representation of the textual representation of HSAL. Oh, okay, well at least we understand now what HSAL is. It's like crappy PTX. Oh, here we have the whole grammar in EBNF. Oh wow, wow, that's a lot of stuff. What? You knew it was gonna rain. That website's pretty good, man. You know, the weather people would be so good if they didn't want to lie to you all the time. You know the weather lies to you, right? Like, we could actually predict the weather well, but they lie to you. So what's the incentive? What incentive do they have to get the weather right? Does anybody hold weather people accountable when they're wrong? Does the weatherman get fired if they make too many wrong predictions? Or is that not the goal of a weatherman? He keeps it real for programming ass the way Nicki Minaj keeps it real for you. Yo, respect to Nicki, man. My friend explained Nicki Minaj to me. He's like, bro, she's just a female Lil Wayne. And I was like, all right, I gotta respect that. Like, you know, she's gonna put your pussy on her sideburns or something like that. I said pussy on stream. Can't say pussy on stream, man. Am I gonna get a content warning again? Please don't ban me again, Twitch. Don't ban me. I understand I'm not suitable for being a partner of Twitch. But you know I'm good at writing apologies, and that's most of what being a YouTuber is. The weatherman. Weren't they like a sorry, freedom fighter? I was about to say terrorist. Freedom fighter organization? What's the optimal amount of terrorism you want in your country? Is the optimal amount of terrorism you want in your country 0? Like, if you could design a country, how much terrorism do you want? I don't know. Who's they? What if you're in charge? You're in charge, you know. We have to, guys, we got to empathize with the deep state, okay? Can we just take a minute and empathize with the deep state? Just everyone take a minute. It won't really be a minute because that's a really long time, but like, I just want you to like think about it. Like, you're a deep state employee. You've worked at the government for 40 years. You've watched it become slightly more incompetent over the 40 years, but it's kind of like a frog in boiling water. You go into work, you do your job. The old platitudes don't really work anymore, but you still repeat them, kind of like the way all of these atheists still have Christian morality. And you do whatever your job is, and you think that you're the government and you're the United States government. You hearken back to a better time, but also recognize that you must change. I saw a great quote. It was like, conservatism is about embracing the failed policies of the past. Progressivism is about embracing the failed policies of the future. Yeah. And let's really empathize. Let's steelman the deep state, because most revolutions don't end well. Most revolutions, it's very easy to tear down, but it's very hard to build up. So you might think about it, you might have your own sort of grievances, but you understand that this system is the only one we have, and without it we'd have no system. So you do your best you can to keep the system afloat. You also recognize that you have a wife and 3 kids in private school in Northern Virginia, And you do need to keep the taxpayer dollars flowing to you. And that really is fundamentally your bottom line. Maybe even a duty sort of supersedes that, but motivated reasoning is extremely strong. You definitely have your own individual gripes with the thing, but you fundamentally do believe in the system. I think you have to. I don't think people are that cynical. I think maybe some people are cynical enough. But I do think they believe in the system mostly. And is the system really that bad? You could end up in way worse places. But I hope everyone enjoyed our empathizing with the deep state. It's important to empathize with people. How do you know I'm not the deep state? Well, I could be. Everyone could be the deep state. How would you actually know? Let's empathize with people who think I'm secretly the deep state. I mean, it is interesting how I did some things that appear that they might on the surface be illegal, and I didn't get in any trouble for it. You know, you always got to watch out for that person. You always got to watch out for the person who like did crime, but is surprisingly not punished for it. Did crime publicly and is not punished for it. That's really odd. So I mean, maybe there's a chance I like struck a backroom deal, and then also the deep state's kind of on a spectrum. So maybe I'm like weak deep state. But I didn't buy an Apple Vision Pro because I don't have those buku deep state dollars. But maybe, what if we're all the deep state guys? I didn't smoke, I swear. That shit, like, I don't know. You know, it's hard. Hillary Clinton didn't get punished for it. It's hard to like drum up tons of hate for Hillary Clinton. You know, I think she ran a terrible campaign in 2016, but we're complimenting Hillary Clinton. Oh. She's just a woman who's trying, Alex.
I do respect that.
Yeah, that's right.
She put herself out there.
Yeah. Are you going for it?
I'm going to the office.
Oh, you're gonna walk into rain?
Yeah.
Watch out for getting wet.
I put this raincoat on.
This is gonna get wet.
Yeah, I have a hood.
Oh, you wanna put your hood on?
Yeah, put the hood up.
Okay. Do you want an umbrella?
I don't think. Do you have one?
My Rolls Royce has two, but we can't use them.
I see my little.
Okay, then.
You just text me when you're done.
Okay. I don't know, but you can't get into these things because they just become people with their preconceived notions of things. But you also can't question everything because the media said thinking from first principles is wrong. And for the most part, the media is right. Because a lot of what thinking from first principles is just searching the internet until you find opinions that agree with your preconceived notion. Because you're not going to go out and do experiments. That's really hard. We live in a society. And part of the society includes the HSA Foundation, who puts out these incredibly complex things that no one I know has actually read. Has anyone here read this stuff? Has anyone here heard of the HSA Foundation before today? Exactly. Descartes' Mr. I think, therefore I am. You know what? GPT-4 thinks, therefore it is too. I'm gonna open it up to non-subscribers. Has anyone genuinely heard of this stuff before today? Like, there's an extreme amount of stuff here. You've heard of it, ultra-scientism. How many people do we have in this stream? 608. was a big thing when AMD was preparing to answer to CUDA many years ago. It seems like they've abandoned this entirely for like HIP, which is just a clone of CUDA. But yet they still kind of support this stuff. Well, okay. Yeah. That HSA is abandonware and HIP is the current stack. So it's kind of interesting. I mean, it looks like from this diagram and from what I'm reading is that all the HIP stuff is just a couple layers abstracted from HSA. Power of Pickle, have you actually heard of HSA? I mean, I guess there's like these people out there who are doing this, like someone's buying these AMD accelerators at their high price point. And so these people are doing like whatever scientific computing is. I don't know. I always wonder how seriously to take these people. Like all the scientific computing people. It seems kind of like I look at their tools and their tools seem to be 10, 20 years antiquated from like the state of the art in the like computer stuff I'm exposed to. Trying to use like you make like a Beowulf cluster and you use what are those? I can't remember the names of them now. What are the? That's like the names of those like. Wow, how can I not even remember them now? I mean, there's a common one that people use in Clang that kind of works. What am I thinking of? You can put like a pragma, like pragma OMP. OpenMP. No, but there's yeah. It's like mpich. This kind of stuff. You know, I just wonder how like seriously to take these people. Seems like this thing is like still up to date. You know, I mean, OpenMP, people still use OpenMP. OpenACC? Wow, another one I've never heard of. Idris. I mean, all this stuff exists. No, there's definitely some great professors out there. I'm not hating on professors. Yeah, we're looking into the HSA Foundation. Well, it also seems like this stuff is mostly like the thing that really matters here is the AMD extensions. So I'm not sure what HSA even is. But this seems to be the API through which all the HIP stuff's actually funneled, which is cool. Just casually try to build this. Don't underestimate the HPC folks. Like, what are they doing? My favorite lesson from the era of like I took a parallel computing class and we did traveling salesman in parallel. And if you write traveling salesman naively, it's n factorial. And the algorithm that everyone was working on was n factorial parallel algorithm. And then one of the guys in my competition programming, I did competition programming, one of the guys just wrote there's a 2 to the n implementation of traveling salesman. And he just wrote that and roasted everybody on the leaderboard on like a single crap core. And then I competed with him and beat him. And then the professor banned the use of the 2 to the n algorithm. And I feel that is the perfect encapsulation of my thoughts on scientific computing. It's like, instead of just using a better algorithm and thinking it through, they're like, we're going to get lots of government funding to get lots of computers, mostly for the sake of getting lots of government funding to get lots of computers to get closer to the deep state. Am I wrong? Change my mind. I'm going to put that on one of them things and stand there with, like, you know, the Steven Crowder table. Well, okay, so like I'm of the also the sort of belief that like science stopped in 1970. Like, what new science have we really figured out since 1970? There's been a few like technological advances. Maybe one of the greatest is like the Human Genome Project, but as far as the core physics and science goes, it stopped in 1970. Sure, we built a very expensive collider to confirm the existence of the Higgs boson, but like that didn't find any new science. So the two hypotheses are that science is getting harder to find, or that something is dysfunctional in our world and the world can no longer do science. And I tend toward the latter instead of the former. Remember, 1969, we landed on the moon and the 747 came out. Today, a 747 caught fire. An engine caught fire. And like, it was fine, but like, that's like where we are. If you ask someone in 1970, if you thought that in, 55 years in the future that you'd see one of these planes, it would still be flying and it would catch fire, you'd just be like, no, that's insane, bro. Like, in 1915, we had the Wright brothers' little shit, and now we have a 747. In the future, they're going to have like delta wing planes with plasma jets. And you just didn't get the delta wing planes with plasma jets, largely due to dysfunction in society, I think. But I mean, everyone's kind of waking up to it. All right, let's look up this Leslie Greengard. Oh, we got TikTok, and TikTok's cool. We got a lot of like the entertainment tech's cool. No, but like, it's hard to understate the effect that deep learning has had. I'm so excited to live through this revolution. 10 years ago, I used to tell my sister, I was like, look, if you want to make a computer program that can tell if there's a chair in an image or not, this is like next to impossible. Because it just was. With 2014 era tech, well, let's go a little bit further back. Let's go to 2009 era tech. Or even back when I first did computer vision. I first did computer vision in 2005 for my science fair project. And it was impossible. Nothing worked. There was no way to tell if an object was present in an image to the point that a 2-year-old could do it. And then, yeah, you fast forward 20 years and, not even 20 years, you fast forward 15 years. And today a child could do that. Right? Like today I could have done that when I was 8. No, I don't believe that all the easy stuff is discovered. I really just don't believe this. This doesn't make any sense. Complex systems? Again, tinygrad is... I mean, we'll see. Look, tinygrad's an experiment. But tinygrad's under 5,000 lines and implements pretty much everything. And there's tons of crap in those two things that need cleanup. There's tons of crap in that one that needs cleanup. I don't think that the systems today have to be complex. I think that it is some dysfunction of governance that has led to complex systems. I think that I think that there's a real misunderstanding of how software is developed today. Software is developed under this, and everybody knows this, but nobody really. Okay, so I'll give another example. 10 years ago, I read the Hutter Prize stuff. Okay, less than 10 years ago, maybe 10 years ago. I read the Hutter Prize stuff, Compression is Intelligence. And I took this to heart. I loved it. But I didn't truly believe that if you build a compressor, you'd get intelligence. But now that seems to be true. So everybody understands these things about software, but they then don't put them into practice. They then put into practice this concept of complexity management instead of complexity reduction. They don't ask the question, how can we build less complex software? They ask the question, how can we get more people to productively cooperate on software? And I think this is completely the wrong question to ask. I think that you want SpaceX's little rocket landing thing is written by one guy. One guy wrote it. And SpaceX has one controls genius, and he made rockets land. And you realize that, check your initial notions when you hear that story. Do you believe that that story is true or not? Do you believe that there's basically one person at SpaceX who wrote the rocket lander? Why don't you believe it? Well, yeah, I mean, there's infrastructure around testing it. I bet he wrote basic tests. But yeah, it takes a lot of people to build a rocket. But building rockets don't look like building software. Look at how Fermat's last theorem gets proven. Why is the proof of Fermat's last theorem, or the proof of the point car conjecture, look so different from whoever wrote Kubernetes? Why are they different? This stuff needs to support all kinds of stuff. Well, again, what you're doing is because you're in the complexity management realm. Once you've decided that it needs to support all kinds of stuff, is like, okay, give me 3 examples of the thing you actually want to support. In general, it needs to support all this stuff as an example of just premature abstraction. Behind every big accomplishment, there's a guy behind it with a lot of less productive helpers around. Yeah, I think that's generally true. I don't think that Fermat had the proof. Once you reach a certain threshold of complexity, you need to refactor. Yeah, you do. And the incentives for refactoring are not there. The way that software is written is fundamentally broken. What the hell? How can one change their aspirations? I don't know, man. I think we've explored how you can actually change, and we were bearish on the whole thing. Do I think I can make Netflix better? Well, that isn't really the question. Like, Netflix isn't really software. Netflix uses software, but a lot of people use software. Like, if you have a calculator that adds 2 numbers together and all you want it to do is add 2 numbers together, it doesn't matter how complex it is. Today, sure, you have some huge computational stack to add the 2 numbers together. Back in the day, you had an assembly instruction that did add. But it doesn't really matter because the API is the same. It's the APIs that are too complex. And then the APIs become, well, it's not just the APIs that are too complex. It's, after seeing Twitter, and after seeing like what happened there, and then everybody kind of justifies it. And it makes no sense. Nobody would be justifying this if for every person they shipped Twitter to, someone had to, put all the bolts in or hand type out the code. They only justify this because software has 0 cost of replication. And software having 0 cost of replication has cost us so much. Why don't I go work at Meta? there's two companies that I'd consider. So, Comma, I never want Comma to be acquired. Comma is very much swimming against the grain company. I have no interest in selling Comma, but I would sell tinygrad. And there's two companies I basically sell to, and one is Meta and the other is AMD. Complexity in software is inversely proportional to the number of people working on it. I think this is generally true. The problem also with Meta is, I saw John Carmack's criticisms of it. They still have, I mean, their VR kind of sucks. If they had put Carmack in charge, I'm sure we would have gotten something way better. I actually don't think Elon should have started a social media platform from scratch. I think that the acquisition of Twitter had as much to do with building a social media platform as and it was really so brilliant and worked way better than, I was excited for it, but if you look at how much the culture has shifted in the last year, if you look at how much the Overton window has moved in the last year, the Twitter acquisition was the best political dollars ever spent maybe in history. When you think about all the dollars that go to all these campaigns that do nothing, all of these just laughable foundations and then left-wing and right-wing, all of them. They're just so ineffective compared to the money Elon spent on Twitter and how much the culture shifted. What's the difference between the culture shifting and my perception of the culture shifting? If everyone's perception of the culture shifted, then what does it matter? He spent a lot of money and made it all back. Unbelievable. All right. The stream's kind of gone off the rails. I think that means it's lunchtime, unless we have one last question. Do we have one last question? What's your last question? Can the entropy in the universe be reversed? Parallel scan, I think we have a bounty for that. I'm interested in it, but all our dev efforts on tinygrad now are focused on making the tinybox good. How do you make money off open source software? Why are you so worried about that, man? Does LLMs are intelligent? I mean, to be fair, I think their grammar is better than yours, so you can judge that for yourself. Your children starving. I'm sorry to hear that. Have you tried feeding them? Is hardware still on the cards? Yeah, we make tiny boxes and we sell them for $15,000. Pre-order one today. I promise you, I'll get the boost mode enabled on the processor. Buy a tiny box. You can pre-order it today for $100 for the pre-order. It's $15,000 total. If you pre-order today, I think it'll probably ship around July. Carmack definitely has practical, useful skills. No hating on John Carmack in this stream. Specialized ASICs? Well, yeah, once you get to the thing you need an ASIC for, but if you don't understand why GPUs aren't good enough, stop. Everyone needs to understand Chesterton's fence. Stop trying to build new fences until you understand why the old fences are there. Many of the problems with GPUs are drivers, are not caused by their hardware. Their hardware is phenomenal. Oh yes, Sutton's on board. Oh, that's Rich Sutton, man. Thoughts on etched.ai? I did a quick phone call with them. God, how do these people get? I just like. Okay, so let's first look at that picture. There's a mid-journey picture of a fake H100. Okay. Here's a graph. Right? This is like meme levels of bad. By burning the transformer architecture into our chips, this chart is meme levels of bad. The long bar is so much longer, big, you know? All right, here's a sideways picture of the same rendering. Build products that are impossible with GPUs. Oh, it's very fast. Compare hundreds of responses in parallel. Generate new contents, right? Like, okay. So, like, can I try it? Oh, you contact them. Oh, it's a mail to. Like, this is a meme level bad website. How does anybody take this company seriously? The number's big. The number's big. I'm like, TenstorRent's website's bad, but it's not this bad. I mean, TenstorRent actually taped out chips. Let's go to the TenstorRent website. All right, so the first thing they're telling me is crap about licensing modules, engineer Galaxy. All right, let's learn more about this. Okay, so what is this? Great, they put lots of things in the things. Okay, well, at least, can we talk about how much better this is than etched? They have some real numbers. It's questionable how usable these numbers are. Okay, so these ones don't expand, but this one does. Oh no, they do. You just need to. Yeah. Okay. Yeah, I think that TenstorRent actually released more on GitHub than I thought, which was cool. Yeah. So this is cool. Like, this is actually pretty good. They have some Discord link. They have Discord link. They got 10 stars on that one and 81 stars on that one. You know, they're coming along. Let's look at the documentation site. It's pretty good, actually. I mean, as far as websites go. They posted on one of my things and offered to send me a card, and I'm like, I don't want a card because there's no point in like what is this Pareto optimal on? I'm not going to spend time writing code for a card that nobody has. That's inferior to what exists off the shelf. Now you have a real chicken and egg problem here, and this is what tinygrad's solving. But I do respect to TenstorRent for like posting this on GitHub, and like, I mean, it looks like cool. I can actually like buy this. We'll call it Intel tier. We'll say this is Intel tier. We can't exactly buy it. Can I click buy somewhere? Okay, it's a little below Intel tier. But there's like etched tier, TenstorRent tier, Intel tier, AMD tier, NVIDIA tier. All right, so we got my tiers here. There's only one problem with NVIDIA, and that it's too damn expensive. Thoughts on extropic? I know a lot less about extropic. We can take a look at what they've. I mean, okay, hype, right? Like, we'll put them slightly above etched tier. All right, let's see what's on their GitHub. Yeah. I mean, let's see what they say about their round. Blah 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 blah. Generative first. So I've heard about this kind of stuff from some smart people, that you can use like quantum learning effects. I mean, I think it's harder to it's harder to evaluate this from this website. Like, this website doesn't really say anything. It's ambitious. I'm generally bearish on, I don't don't know, actually. Like, here's kind of my thoughts. If I was being asked, should I invest in this company? I probably wouldn't, but I'm pretty conservative. If I asked, should this company be funded? Like, I think that the $14.1 million that was raised by this, I think that a much better funding model for companies that look like this would be if, like, science grants weren't clown shit. Like, this is fundamental research that needs to be done. As far as I know, none of this stuff actually works. And what you want is this research to be done openly, and you probably want governments to fund it. So instead of giving whatever clown money goes to whatever clown global warming clown shit, like, I would much rather that instead of their seed round being raised from VCs, it's given by the government on the condition that the research is open. I don't know. Again, they're individuals. They can choose where they want to get money from. And if the markets want to fund it, then, you know, more power to the markets. But I'm bearish in general on startups that require fundamental research to be done. So yeah, like, if you ask who I'm bullish on Perplexity. Perplexity can actually kill Google. The bar for Google has gotten so low that, like, this website made good could actually kill Google. If this box was a little bit better, I'd never use Google again. But I mean, I'm interested to see what they do. I feel similar about Extropic that I do about why can't I think of their name? The Sam Zalou startup. Why am I blanking on the name? What's the name? Let's see what their website looks like. Atomic Semi, yeah. I'm more bullish on this than Extropic. This is actually, maybe this is yeah, you know what? I am bullish on this. I'm bullish on this because what a company should do is figure out how to take research and make it cheaper, faster, and productionize it. So yeah, I'm bullish on can we build trailing edge fabs that are 10x cheaper than it costs to build the trailing edge fabs today. I think that there's a real niche there. Yeah, so I think we'll rank these: etched, Extropic, Atomic Semi. I'll actually put Atomic Semi above Tenstorrent. Let's say etched, Extropic, Tenstorrent, Atomic Semi. Tenstorrent's given me a lot of look. I have a lot more faith in them for actually releasing this. I'm curious if anyone's actually really used it, but I mean, it is open source, and it seems like also it's not just open source, but they've thrown their entire commit history on here, and they're developing in public, so they're doing a lot right. I don't know. Seeing this repo makes me so much more bullish on Tenstorrent. But let's look at actually what some of these things are. I don't know about. I think it's very complex though. Add max pool 2D. Let's see what it takes to add max pool 2D. So we have here, we're determining the parallel config specifically for max pool 2D. Oh, this is NGMI. So a big difference between tinygrad and pretty much every other deep learning library I've seen is factorization. So Torch will compile a different kernel for maxpool 2D, maxpool 3D, maxpool 2D on CUDA, maxpool 2D on CPU, maxpool 2D on CPU with uint8, maxpool 2D on CPU with float64, maxpool 2D on rocm with bfloat16. And those things become a multiply instead of an add. In tinygrad, they're an add and not a multiply. You can think of the concept of factor graphs. So like we've factorized each of these different things such that we don't have a multiplicative effect, we have an additive effect. That's kind of my like philosophy. I can go way more into depth on that. But yeah, I think that things that are like, yeah. See, this is NGMI shit that should be beam searched. Literally, like the ResNet shapes are being hand coded into the maxpool 2D. But again, the tier difference between this graph and this are like massively different. This is, at least they're doing things right and are open to criticism. And this is what I mean. I think this is from Curtis or maybe from Mike Solano. Do you think that the NSA or the DMV are better run? And the answer is you can at least see how much the DMV sucks, and there's some mechanism to hold them accountable. Buddha's a good name. They didn't have this last time I talked to Jim. I think it's funny. So yeah, here's their driver. Looks pretty minimal, which is cool. They did a good job with that. You want to put as much of this stuff in user space as possible. Like, this is a pretty minimal kernel driver. How does Perplexity make serious money in the long term? Okay, so some guy said that like I came up with the idea years ago. If some of you watched this stream, again, ideas are completely worthless. Everybody knew about this idea. You're like Hammer's mission to organize the world's information, make it accessible to anyone who pays a Hammer $30 a month. Well, there's your Perplexity business model. Here, you want Perplexity's motto? Don't be evil. And if we ever remove this model, it's because we are evil now. Their slogan: better search, better results, Perplexity. Right? You can literally just replace Hammer with Perplexity, and they have the whole business plan here, and it will be a successful company if it's actually good. Well, we have to hope the founder agreed to an unbreakable vow of never becoming evil. Should this be the paradigm for web dev? Let's take a look. Oh wow, that's so good. That's such a nice website. It loaded so fast. It didn't have 32 pop-ups on it. Yeah. No, like I actually don't think that like you don't have to make your website look like it's like from the 90s. Like you can make a modern looking website, but don't put 7 megabytes of JavaScript on it. In fact, the right amount of JavaScript is 0 megabytes. Stop using JavaScript on your website. Like, it is a great tragedy that web browsers support JavaScript. I should just like no script should just be like more of a thing. Stop using JavaScript. Cookies are fine. Cookies are actually so much more fine than JavaScript, right? A cookie just in the sense of there's some way to identify to the back end that like you're the same person. You want a cookie. Cookies are great. No one should have a problem with cookies. But JavaScript, yes. No, JavaScript, no. TypeScript is not better. The problem is that you put a programming language in your web browser. Stop doing this. So yeah, there you go. Right? There's Perplexity's business model. It succeeds. I'm on the verge of signing up. If they show me that signing up will get me better results, I will sign up and pay the money. No JavaScript. People cannot. No. You had JavaScript and you abused the privilege. So now no JavaScript. That's right. Well, okay. That's not a website. This is a chat interface. I do respect that this chat interface needs a little bit of JavaScript. But like, I'm upset that there's any JavaScript on this. I've complained. I want Comma's next website to not have any fucking JavaScript. Okay? You know what doesn't have any JavaScript? tinygrad's website. No JavaScript. Right? Like a video element's fine, but like I actually think this drop down is JavaScript, and it shouldn't be. It should be CSS, which I understand is Turing complete too, but yeah, no JavaScript. Thoughts on the Rabbit? Rabbit falls into a, if something costs $200, a whole lot of people are going to buy. Rabbit is just the STEM player of AI. The Rabbit is the STEM player of AI. Like, did anyone here buy a STEM player? Apple's website is pure CSS? Oh, I'm sure they have JavaScript on here. Goddamn JavaScript. JavaScript. Okay, at least it doesn't look like a lot of kilobytes of JavaScript, but there's still JavaScript here. What's data relay? Oh, we have metrics, auto relay, locale switcher, AC global footer. Yeah. And let's look at some JavaScript. Oh, determine if an object is a buffer written by Faraz. Yo, Faraz is great, man. Like, it's just crazy. It's just crazy. Like here we are clicking around things and we found Faraz. What is this? Why does Apple's website have a fly out? Oh, yeah. Good thing. Oh, that one. This one was nicely formatted. This one was not. Oh, the minifier. Global header UMD. Why? Oh, what is global header UMD? Why do we have this? Oh, University of Maryland. Oh, here we go. Oh, it's in PDF.js. Oh, UMD modules. That's right. JavaScript is canceled. No, WASM's not better. No, it's not better. Stop it. No, the problem is you put Turing completeness in things. No, don't put Python in the browser. The problem is not the language. The problem is that there's a programming language in the browser. You take out your Rabbit. What is this? This is some funny green text, bro. All right, I gotta shower and go get food. Thank you for watching today's stream. Hopefully we all learned something today, and we learned that we don't have to write a whole thing. We don't have to write a whole driver. We just need. That sort of helped push my career into the. Wait, what? Lonalox has 5,000 viewers right now? That's crazy. What's happening right now? Well, we're going to go over there and you guys can check it out.
I made their move count. We've guaranteed 100% accurate taxes for millions of new homeowners. Intuit TurboTax.
Yeah, but that's okay. It's first-person survival, single player, narrative. There's crafting in, there's
dude, let's find out why Lonalox has 5,652 viewers right now.
NPCs in, combat, exploration.
I love you all.
But I've made hundreds of items that you can scavenge and find and combine and cook
we have
and
to
craft
recognize
and
that
to build
everybody
different
has
benches that allow you to do
incentives.
different
Some of
types of
them just don't align
crafting,
with
like
yours, and
welding,
that's just the world, man. That's
electronics,
just the world. If you're thinking about killing someone,
stuff like that.
I would advise against it, but I remember that everybody has different incentives, and you can do what you want, because
And
I
so,
believe fundamentally
it's all
in freedom, except when it comes to killing
I'm
people.
working on the
If you
narrative
do
part, so
that,
I've been adding a lot of
you should,
environmental
go
stuff
to
in.
jail, because we need to make crime illegal.
And
Otherwise,
I haven't
we don't live
optimized
in
the stuff at
society,
flag right now.
and I have some
But
bad
that
news for
it's
you.
just a matter of
We
like
do
turning
live in
things off and
society.
on when I don't need them. So it's not a big deal. I just got to spend a day doing that, organizing. But bear with it. And I also run really fast. I'll show you guys the NPCs because they're pretty fun in the